So today's session is going to be about NumPy, and I would kindly like to invite Mr. Kwesiba, Mr. Emmanuel Kwesiba, to lead the session. Sir, please, you are welcome.
All right, thank you. I hope you can hear me.
Yes, sir, we can hear you very clearly.
Yeah. So, as you mentioned rightly, my name is Emmanuel Kwesiba. I'm with Lancaster. Yes. So we're just going to go through this together. Thanks for having me, and then thanks to Sir Richard for the time and all that he shared last week. If you had any question, please, you have to make sure you resolve all the things he shared with you. So, as the moderator rightly mentioned, we'll be looking at NumPy today. So, if you have your Kaggle account, it's better you just create a notebook. I'm trying to use the same thing so I can run through with you as well. Are we on the same page? I hope everything is fine. You can hear me. Get your environment set up, and then we start from there.
Okay, sir.
Are we good? Are we good to go? Yeah. Okay. All right. Sure. Thanks. You can see my notebook, right? Hello. You can see my notebook.
Yes, you can see.
All right. So I was trying to look for the Google templates you guys used to create your slide. I couldn't get it. So I will actually copy from where I have the material in here. So you could just look at what you'll be looking at for today. But I just hope the time will be enough because the content is too much for the 1 hour. So straight ahead, we will look at creation of arrays, first of all. So the things we'll be looking at today, creation of arrays with NumPy, then the various types of array we have, and then the attributes they have. Let me just copy these things here. Sorry. Yeah, and then from linear algebra. Yeah, so basically this is what we'll be looking at today. If we have enough time, I just hope that the 1 hour will be enough for me. We spent, 8 minutes. Roughly, everyone should be able to. If you have your machine, practice is better. Yeah, I would love that. You just attend this to a markup rather. So creation of arrays with NumPy. Since Sir Richard has done all the basics, I wouldn't have to bother myself with everything. So yeah. Yeah, so for any Python library, the first thing you are told yesterday is that you have to first of all import that particular library. Python is all about libraries. Yeah, everything is a library. Even to sort, to search, everything just a library. And the way to do that is simply to have your imports, and the IntelliSense is there to help you. Simply NumPy. If it's not there, you have to actually do a pip install to get it. And this is common for almost every data science or ML work you'll be doing. So import NumPy and use MP, right? So this is basically how to import that. But what is a NumPy in the first place? We are saying it's a multi-dimensional array, and typically used for both data structures for creating, accessing arrays. And it doesn't only work with numbers. Yes, the interesting thing is that if you have a text data, video data, audio data, it gives it. So, for example, the normal text data is or numbers is just one dimensional. For two-dimensional data, like you have an array, right? It uses the two-dimensional form for it. But if you have images and videos, it gives it for gray images is two-dimensional. For colored images, there's a third dimension, like for RGB images, right? There's a third dimension or three-dimensional array in terms of number representation. Then if you have a video, there's a fourth dimension to the array. Okay, so this basic understanding is there to help you to get this why you need NumPy. So typically I'm working on a video data set. So it has to, if I'm not going to use the first component, I may just have to convert everything into series of frames. That actually would mean I'll use a three-dimensional color component for that. Okay. And again, if a two-dimensional table might actually store the samples, and each of the samples would have been divided into what we call features. So you have a look at an example practically, if our time permits us to do so. Okay, so that's by way of introduction, a library that handles multi-dimensional data sets. Particularly, we have matrices, which is either a single dimensional or multi-dimensional matrix, and vertices or eigenvalues, and then how to decompose those ones and apply linear algebra or computational methods to them. That's basically what we're talking about. So I hope that is clear enough for us to progress. Right. So this is how you do that. You import, usually it's actually there. So for most Python environments, NumPy is automatically embedded as part of it. So let's try with the first one, creating an array. So the first thing is that there are several ways to create NumPy arrays, right? You call the variable you have here, or the initialization of the library you called, which is MP, right? And you have your array. And then, so a quick question. What's the difference between a list, a tuple, and a dictionary? Yeah, the audience, let's see, do a quick test. Audience. Audience, quick test. Differences between.
Hello.
Yeah.
So please, good evening.
Good evening.
So when we talk about tuple is an ordered immutable collection of items.
Okay.
Example.
What immutable means, you should be able to explain immutable.
All right. So immutable means you can't change it.
Mm-hmm.
In
All right, continue.
a sense that, example, when we have something like maybe my tuple is equal to Kelly braces, maybe 1, 2, 3. Then maybe print my tuple. Then you maybe the index of the number that you want to print may be 1. Then the array will be 0. So the output will be 1. Let me try to type it in the message chat.
All right.
So in this case, the print function is going to print 1.
Okay.
Yeah.
And go ahead. I'm listening.
Okay, so when we talk about list is an ordered mutable collection of items, meaning you can change the items in the square braces.
Yeah.
So the use case may be maybe if you want to append any digit, So let's say you have my list is equal to 1, 2, 3. Then maybe you want to append maybe 4 in the index 3. Then it will be my list dot append 4. Then you print my list, so it will be able to print the 4 numbers. So let me try to type that one too for easy explanation. So it's my list print.
I hope the rest who are also listening. I think I don't know whether this topic was treated well in the other section, because you need to understand what we're doing here. I'm sure, moderator. I'm sure the that was part of last week's session. Is that right?
So we did talk about lists, but just that, due to the time limitation, we were not able to, like, let's say, go deep. But then we were given exercises to do on Kaggle. So if everyone had should have done this, I'm sure they will be clear with the list concept.
Okay. All right. Sure.
Yeah.
All right. So the reason I'm saying that is you'd have to be conversant, because we are building up people who understand these things. So how do you know something is a list, is a tuple, is a by representation?
Okay, so when we talk about dictionary is represented in a curly braces. When we talk about list, it's represented in a square braces. Square braces. Let me say it that way. And when we talk about tuple is represented in what we know as brackets.
Okay.
Yeah.
All right. So that is what I needed everybody to understand, so that as I bring the things, you'll be like, why am I doing this? Why am I? So for the arrays, we use what we call a list, right? For that. So let's say I have this array, array 3, 4, 3, 5, and 4, 5, and 6, right? So
yeah,
it will be printed as an array. So this is what a list. That's what I need you to understand. Are we together?
yes, sir.
Now, this is a single,
Yeah.
this is a single dimension list. It's just a one dimension list, just consisting of only row. Now, if you want to have a multi-dimensional or two-dimensional list, you can actually do same MP, then you call the array, right? And in this case, you define that with your basic programming, or maybe if you've not done a bit of programming, or what it's called matrices. For a multi-dimensional array, you have one, this is the first, and within that two, you have the actual list itself. So let's say this one, I have 1, 2, 12, 13, 14, right? This is just, let's say, the first row. This will represent the first row. And I'll bring a two-dimension, another row. That will be this 15, 16, and 17, right? So this is by way of, can I write or draw here? Like Zoom, can I annotate if I want to draw, write something? Let me see. I'm not too sure. I'm not too sure about that. Yes. Yeah. Oh, I think I can draw on the, yeah. That's good. So let me just do that. Oh, I thought I was able to do that. Yeah. This is what I wanted. Yeah. So what I've done here is what I wanted to represent in a matrix form for you. So this is 12, 13, 14, 15, oh Jesus, 16, I have to change my 13 again, and 17. All right. So last week you were taught the single dimension list. I remember Sir Richie was explaining to you. You have, let's say, 1, 2, and let's say 3, right? And he told you that the indexing starts with 0, 1, and 2, if I'm right. Then it says if you are counting from behind, it's -1 from here, -2, and -3. Do you remember this? Yeah. All right. Eraser. Okay. Oh. All right. So I need you to get this so that you understand what's going on, because you'll be doing slicing and all of that too over here. Right. So this is it. So once I click on run, I should be able to get that particular array that I have here. Right? Are we together?
Yes, sir, we are.
All right. Okay, great. Again, hey, this online teaching, you have to again, you can have, so I want you, based on this, if I wish people join their screen, because sometimes you like students to also do. I want a 3 by 3-dimensional array, right? A 3-dimensional array. If anybody could just help with giving up a 3-dimensional array consisting of a list of lists, right? Let me just, yes, somebody's talking. Somebody can show us something. All right. Since there'll be a challenge having to get someone to do that, let me just do. So as I mentioned, similarly, you can also have a 3-dimensional array. So this is a 2-dimensional. Who is there?
Sir, I'm the
Mr.
one,
Derek?
the moderator. Yes, sir.
Okay, all right. Yeah. So as I said, I wanted a 3-dimensional array. Any demonstration of a 3-dimensional array will be able to help us. Need I stop my screen before you share your screen or something? Yeah, I'm waiting.
Yes, I think that's the case.
Oh, okay. So I can stop so that you share your screen.
Okay, let's share my.
Yes, those who are also joining with their laptops, you can actually do same. Try and create something like that. And
Hey, my screen. Sir, so that is what I did.
is this 2-dimensional or 3-dimensional? No, it's 2-dimensional. It's 2-dimensional. I'll explain to you why. Yeah, it's 2-dimensional array. Yeah. So you can see that from the 1-dimensional array, you just have one list.
Okay, sir. So I missed it. Another.
A 2-dimensional array. Yeah, I know. That's why we are here to learn. We are all here to learn. Yes. So a 2-dimensional array is a list of a list. So this here is one list of this particular list here, right? The 3-dimensional array is going to be a list of a list
share your screen.
of a list.
Sorry.
Oh, sorry. Sorry.
Sir, please can I share?
Yeah. So let me just share my screen. Oh boy.
And also, sir, there are some listings in the chat. Some people have posted some solutions in the chat.
Oh,
also.
okay. I'll have to have a look at it. I'm the one teaching. I'm the one having to look at these things there. Yeah. So let me try and have a look at what's in the chat first. Yeah. Okay. So yeah, I think George has got something right. Yeah. George has got something right. Yeah. So, but the concept is, you see, this, in this case, we have, look, this is how to know the dimension. Is the number of lists at the openings. That will let you know whether it's a 3-dimensional or 2-dimensional array you are creating. Right. So you have a list of a list of a list in here. So in this case, now what is inside will determine the element inside the list. So you can have that one as many times as possible. Right. So you can have, like, if the numbers I'm using, 13, 12, 13, I can start to make it 3, right? 14. Then I have another list, right? 15, 16, 17. I have another one within this, 18, 19, and 20. Right? Are we together?
Yes, sir. We are with you.
Yeah. You can also decide to modify the dimension of the whole thing by grouping them into 2 portions, either if you want to, or 3. Let's say if I decide to put one extra thing here, right? Let me run this. I know I will run into an error. Yeah, because the thing is not balancing. Yeah, so let me just delete that. Yeah. So basically that's about it. How about if I give you the output and I ask you to produce a code for it? Right? How about if I give you an output like this? I want to see whether you'll be able to do this. I think I have a lot to do, so I should be able to and then this is 8. Okay. And this is 15. Yeah. How about if you ask to produce something like this? Sorry. You have to produce something like this as output. How do you code this? How do you code this output? A challenge. How would you be able to code this output? Yes. Anyone to help? In the chat. Anyone to help? Or maybe if you are ready, you can just tell me so that I just do that. Yes. If it's about teaching, I can just run you through the whole thing and we'll finish. But we want to understand practically. That's how come I'm doing this. Yeah. But I have 30 minutes and I'm not even done. Just even quarter of what I have to do today. Yeah. So basically, just looking at this. So you have 1 and 1 and 15, right? And then you see there's a comma there. So you bring the comma, Then you have another list, which is -5 and 8. Okay. And there's a comma after 2 braces. So you just leave those two, you bring those 2 braces, right? Like this. And then you bring your comma. You produce the other list, which is -12, 0, 8. Did I say -0? This is not a good question. You have -0 at all. Sorry. Yeah, 0. And then you have 9 and 8. This should be correct. Wait a minute. Oh no. Let me diagnose 0. Sorry. Um, 115. This.
I think a bracket is missing, like a parenthesis, sorry.
That's what I'm trying to trace.
Like just after array, NP array
Oh,
is parenthesis.
can you imagine? Oh, sorry. Thank
Sorry.
you. See, that is it. Your mindset is somewhere else. You're not even thinking. Yeah. So this should be correct. It's not the negative. Well, anyway, that's how the thing can be. It's not a negative. Yes, this is correct. Yeah. All right. So something as basic as that is causing me to delay. Yeah. So that is it. Again, you can also have an array you generate by filling all the content of the array as 0. So MP array. Then sorry, this one you don't use array, you just use the word zeros. It means that you want the content of the array to be filled with 0. All you have to do is specify the dimension that it has to be, right? This is a function helping you to create a type of array that's filled with zeros. So let's say 2 by 4, sorry, 4, right? Hey, sorry. Yeah, you put it.
Sorry, can I ask a question? A quick one?
Yeah, go ahead. Yeah.
What is this, like the last array you did, like with like array and parentheses and 3 curly square brackets and like 2 separate arrays, like -1 0. What is this? Is it like a triple or a double, like a double dimension or 3 dimension? Sorry, what is this?
Did you just join or you were here before?
No, I just joined today. Sorry.
Oh, okay. Yeah,
No,
I
no, just
understand.
briefly, if you tell me, like, if it is a.
Oh yeah, I'll explain because I talked about. So when you see the first 3 lists over here, it's telling you it's a 3 dimension. We dealt with the 2 dimension here, right? So this will let you know the dimension of the array, and this is 1 dimension. Are you okay, my friend?
Yes, these are like clear, but I don't understand just the last one, like
The last one.
Yes, like the
Yeah, sorry, this one.
Yes, exactly, this one.
So this is a 3-dimensional array consisting of 2 separate two-dimensional arrays, right? So this here is one separate two-dimension within the three-dimension, and this also here is two-dimension within the three-dimension. Is that okay?
Yes, yes, thank you. It's clear now. Thank you, thank you.
All right, that's fine. Okay, so as I said, you can also create an array consisting of zeros by just specifying the dimension. This is 2 by 4. I understand, I'm sure you should know the 2 by 4, where 2 is row and 4 is column, right? So you can just modify that 3, 4. That should tell you, can do 5, this, right? You can do as many as whatever you want to do. Nobody cares, right? Any dimension you give it. You may have a limit though. Yes. All right. So again, you can also specify the type of integer instead of floats, or use the other parameter we include when we are specifying the zeros as mp.zeros, right? And you put your function into your parentheses. Let's say this is 5, 9, but we want to specify the integer type it should have. You can see that this one is actually floating point, is 0 point. It's actually 0.0000. Yeah, that's why 0 points. You don't bring the zeros. But if you want to use an integer, you can specify the data type, right? So we have D type, right? And you specify as int, right? So it moves the dot thing from there. Are we together? Yes. Similarly, you can, instead of zeros, you can use ones, because when you're dealing with particularly for zeros and ones for black and white images, you can just do this, right? Okay. The same thing. You want a 5, this. Okay. All right. But how about if you want 3? What would you do? Would you, or you want the number 2? Would you say mp dot twos? Would that be correct? Would that be correct?
I don't say no.
Why?
I say I don't know, but I just do it.
Okay. Okay. If you had said yes, I would have been like, this is not possible. Yes. So if you want to fill it with a particular kind of number, you use mp.full, right? And then you specify the dimension. What the dimension here is, let's say 5, 9. Still using a 5, 9. And then you specify what element you want to fill it with. This case, you want to fill it with 2. So the value you want to fill it with, right? You just do fill value and you say 2. Okay. And to do that for you. Are we okay?
Yes, sir.
All right. Okay. So let me do this and see whether, let me do this. I hope you understand what this means. Right? I want somebody to interpret what I've done. What I'm doing here is that I want a 3-dimensional. So this is row, column, and this is the depth. The last one is the depth, right? Now I'm filling it with what? 2. The depth is this is the first one, and this is the second one. Are we together?
Yes, sir. Yes, sir.
All right, that's fine. Okay, so let me just quickly move on. We also have you can use the empty numpy.empty to also give, sorry, to also give an arbitrary,
Oh, sorry, sir.
yeah, an arbitrary representation, right? Let's say you have something like this. Oh no, wait.
You misspelled empty.
Spelling of empty.
Yeah. Yeah. Let me do this and see. 5, 4. Let me see. So it's this one. You don't really have control of how it will be able to, what values will be displayed in there, right? Let me see 1, 3, and see. Four, 3. Yeah, so these are how to generate random numbers for you, right? But we will look at how to actually seed the random number such that anytime you do these things, you can get exactly what you're looking for. We also have another function called the I function, right? That creates an identity matrix. Now, what's an identity matrix? An identity matrix is a matrix that its diagonals are set to 1 and the non-diagonal elements are set to 0. So let's just look at an example, right? So mp dot I, we use I to get an identity matrix. And then you specify the dimension of the identity matrix, right? So you can say 4, and then you specify the data type it should give you, right? So D type is equal to, if you don't specify, by default is what? Is float. Okay. If you specify D type, it has to be what? An integer. Then it should give you something like this. So we're saying that the diagonal of the matrix is set to what? 1. All the non-diagonal elements are set to 0. Are we together? Okay, the next function, so it's just since it's a library, what we are doing is that we are just exploring the function that the library allows you to do, so that in your project, or you're working on a project that demands that you use NumPy, if you have to call any particular function, you know what the function is specifically doing in your program. That's why we are going through this one by one, right? You may not be able to exhaust that. We also have the arange function, right? The arange function works like the range function, right? But it produces the array instead of a list, right? So let's try and look at the arange and the range function and see. So mp dot range, right? And so in this case, I suppose 0, 10, and 2. Now the 0 is the beginning of that particular array or list. The 10 is the ending of it, and this is a step between the elements, right? So this should give me what? Oh, NumPy has no range. Okay. Well, it uses a range rather, but yeah. Yeah, so this is it. Unlike the normal range, for example, give me a range of multiples of 2 between 0 and 10, or from 0 to 10. You tell me from 0 to 4, or multiples of 3 from 0 to 15. 0, 3, 6, 9, 15. Yeah, those things. That's what this A range does. Right. It produces what's an array for you. Okay. So for non-integer range, we use, this is for integers. Okay, if I should change this to, let's say 3, like what I was talking about, and this is 15. Who can guess the answer? Who
It
can
will
guess the
print
answer?
three,
Sorry?
multiples of 3 up to 15.
All right. Why didn't it include? Yeah, excluding the number. Yes, that's what I should have explained. Excluding the number, the last number. Yeah. All right. So this is for integers. What for non-integer ranges, you would have to use. You don't use a range, right? MP, you use len space, right? Len space, and then again you look at the beginning, and then you look at the ending, right? The last item you'll be looking at, okay, and then you look at the step. So in this case, let's say you want to get you want to use a NumPy to call the pi. You know what a pi, right? The normal pi, 22/7. Okay. And in this case, you want to step every evenly spaced range with 5 elements. Right, with 5 elements. So this one, the 5 actually here represents the number of elements you would want to have. So you have 1, 2, 3, 4, and 5. And you can see that the last number is actually the pi, where the pi is 3.1415, blah, 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 like that. Okay. So with the length space, we are saying that one does not have to compute the length of the step. Take note of that. You only have to specify the number of elements you want. Take note of the difference between the A range and the length step. Right. I wish you guys would do an exam if you are going to get a certificate. Is there any certificate for this? Moderators?
Yes, sir, please, there's a certificate after the exercise. There's a badge. Kaggle call it badge certification.
Okay. All right. All right. That is for the Kaggle, or the Kaggle has got the one for the pandas and the, I think the math lab, math plus lab, and not for NumPy.
Yes.
NumPy is for the other one that's link that was shared, the courses.moc. Yeah. All right. So how about if you want to use, you want to test your program using real world data, okay, and the data is not available, NumPy can also help you to create random data, right? Generate random data easily as your sample for a distribution you want to work on. Okay, so with that, you use the random function in the library. Okay, so let's try and look at generating random samples. Sorry. Okay. All right. Hey, time is gone. Wow. Okay. But yeah, random dots, and then you specify the random sample you have. So you call random dots. The random function has got a sub function called random, right? It takes, now the IntelliSense actually should give you a clue as to what is happening, right? So here, random, where is it? Yeah, right. So it's telling you it takes the size of the elements you would want to have. That is the random, yes. You can also have random integer or random sample, where you just have to specify the size. Okay. So it returns floats, returns random floats in half open interval. Half open interval is between 0 and 1, where 0.0 is the lowest and 1 is the highest. Right? Okay. So in this case, you specify your range, right? You specify your range for it. So in this case, what are we doing? You have where is it? If I want a 3x4 dimension, you just specify 3x4. Or if I want a 2x5, you specify, and it will generate the random this thing for you. Wait a minute. Oh, every day then this parenthesis thing will be, yeah. It will do that for you. So this is a 2x5, 2 rows, 5 columns. Right. So you can do that too on your own. Again, you can also use the normal to have a normal distribution with a particular range, sorry, a particular statistical type, like the mean or standard deviation. Okay. So if I should have something like this, np dot random, this, we are just exploring the random function, right? And we want a normal distribution, right? So with this normal distribution, the first item is the mean. It takes three arguments, 1, 2, and then 3. So 1, the first part of the parameters the function takes is the mean. The second part is the standard deviation, and the third part is the dimension of the array you want to generate, right? So in this case, I want a mean of, say, 0, and then a standard deviation of 1, and I want an array of 2x5, right? So it will generate random data for me that will fall within that particular range. Are we together? It means that if I should be able to copy this random element and try and find the standard deviation, I'm supposed to get a standard deviation of 1 and a mean of 0. That's what it means. Okay. Then we also have random integer. All we've been doing is floating point numbers. How about if you want to generate a random integer? So random, and then you have rand int for that. Okay. So in this case too, it takes the lower, it takes the upper, and then it takes the type of the dimension of the array. So it's also taking 3 dimensions, right? So this is starting from, let's say, -5, -5, right? To, let's say, 15. And the array I want to specify is 2x5 dimension. And they should be able to do this for me. right, generates random numbers for me. Are we together? Are we on the same page?
Yes, sir. Yes, sir.
Yeah, but again, let's say you have generated this random number. Let me try and run it again. You see what is happening? The numbers is generating keeps changing. How about if you want to make sure the numbers remain constant and they do not change, right? So in that case, what you do is that, let me just copy this one and then come show you. Oh, you introduce what is called the seed. So mp.random.seed, right, 0. And then you can now go ahead with this. Let me try and see how this will go. I realize that it's not changing. Are we together?
Yes, sir.
Okay. So whenever you want to, for example, if I have a normal distribution like random, and then you have what do you call it? Normal, right? You specify the mean, you specify the standard deviation, you specify the range of numbers, right? And you go ahead to do this. Oh, let me print this too. I'm sure you know the print function right now because you did that last week. Right. So you can see that the values I'm generating are still the same, right? Both for the normal distribution and then the random integers are generated over here. All right. So let's talk about, do we have any other thing you need to? Yes. Another thing you also need to know is yes. Somebody says, say, please, I'm listening. You have a question, just go ahead. Hey, or the person was a mistake. All right. So you can also have what is called you have another function called random state, which is also a class within the random function that gives you the seed. Now let me just give you a typical example. Where is it? Let me just demonstrate this one too. Then I talk about attributes. Let me see what I've been able to achieve today. So creation of arrays. I'm not going to attribute and array types and attributes. Jesus. So it take you how many weeks? Anyway. So let me just talk about the mp random state. So it's a container that takes a seed value, right? So what does this do? The random state and the generator expose a number of methods for generating random numbers drawn from a variety of probability distribution. In addition to the distribution, each method takes a key argument like a size. If it's not specified, the default is set to none. Okay, yeah. So why am I doing this? This to help you in case you want to understand what the particular class in the function is doing. You can actually read this one to get more insights in regards to this. So let's say I want to get integers that are fixed, that are generated randomly, right? I can do that. I can do that also here. So I have random, yeah, and then I see this to 1, 2, 3, right? Then I can assign this a value of generator, because this, I'm just assigning all the things I have in there, right? So that whenever I call the new generator, it will be able to use that particular seed to do the randomization for me. So unlike this place where I didn't assign the seed thing to anything, I just have to do this here. So when I say n underscore generator dot random rand int, what it does is that I can now specify the range, the number, and then the type of number of elements I want in there. So this should give me 10 random even numbers in this particular order, right? Yeah. Let me change this and see. Okay. Moderator, do I have some more time? Or we have to end here? Or maybe I should allow time for questions. Operator. Hey, is moderator here?
Yes, I'm with you. My network, yes, the network is really, really terrible at my side. That's why I've gone mute.
I'm a very time conscious man. So I know I've eaten 3 minutes of your time. That's why I'm asking the audience, can we continue? Can we break? Yeah.
Yes, sir.
Okay,
Which
so
one
I
is the
think
yes?
maybe we should just put into the comment section or something, or should everybody unmute because it will be kind of rowdy here. So maybe we should
Time
put
also.
time as
Thank you. I see that people are doing that. Times up, times up.
yes, yeah,
Yeah.
thumbs up.
So
yes, sir.
let me give assignment. Assignment. I like assignment now.
Okay, sir.
Please take screenshots of the assignment. If you are my class there, I'll give assignment. Don't worry. You like the assignment. Okay. So using your knowledge obtained here today, create, please, you can just take the assignments and then you just, okay, sorry. Obtain here on NumPy, create a 2-dimensional and 3-dimensional arrays to what again do you even do here? Because some of you will not be practicing. Yeah. The second thing is that create an integer array of dimension 5 by 5, then generate a normal distribution of floating point numbers of size 15. Yeah, so this is it. Sorry, no. This is it. So you are at liberty to now go. You can take a screenshot of the assignment. We'll continue on Friday. So moderator, based on this, thank you for your time. I'll meet you on Friday. I sign out. Moderator. Hey moderator, where you dey? Executives, can you take over?
Hello. Yeah, Emma.
Yes, sir.
Oh, okay. I think the moderator is off now. But anyway, thank you for, this great insight on NumPy for us. Yeah, for those who know, I'm Dr. Pong, the DDD advisor on campus. And it was very tough getting Emma, Mr. Pisiba for us. So we are much grateful. And we'll continue on Friday for us. And if possible, we don't get to finish on Friday, it's likely we'll extend his session to Monday so that at least he takes us through whatever we have to do. And please, let's be time conscious. We start exactly at 7 and we end at 8. Today we have eaten about 8 minutes of our time. And I want to just say that for all ICT members who join, will be handsomely rewarded when we return on campus. So that'll be it for now. Have a good night and we'll meet again on Friday.
Yes, the assignment, don't forget. Next week, you present your assignment. You share your screen.
All right, so I think that'll be it for now.
Okay.
Have a good night. Okay. All right. Bye.
Please, you mentioned something of the certificate. How we want get the certificate? Uh, please, how will we get the certificate? Hello. Hello.